Previously in the semester, we defined and talked a bit about novelties. So before we start looking at these specific examples that we're going to cover in this unit, I'd like to just do a quick review and definition of that discussion that we had earlier in the semester. So in very broad terms, a novelty is any morphological structure that we don't have a clear understanding of its origin. Now realize that there can be different grades of that. There can be things that we just really have no idea at all. There can be things that we kind of have some ideas about, but maybe there are two or three competing ideas. And then there are ones that we understand fairly well and we know their origin, and but they serve a brand new function, and so those could be classed as novelties. So a morphological novelty really could fall under a number of categories, but at some level it's something new that gives organisms new abilities, new features. So for instance, and there's not a lot of research and data supporting these first three. These were ones that are still open for investigation, and there are many others also, but antlers, horns are different. Horns are extensions of bone that grow out. Antlers grow from the outside in and are a little bit different in the way that they form. So antlers in the cervids or the deers are a morphological novelty. The flukes on the tail of whales are morphological novelties. These allow these organisms to do something brand new and adapt to their environment in ways that their ancestors couldn't. And the three inner ear bones in mammals. Now realize this is a good example. We know where these bones came from. If you look historically, you can see the ancestral bones to these in jaw attachments. And then there's a fairly good series of extinct synapsids, the ancestors of the mammals, and we can see the modification, and we know the origin of these bones. Even though we don't know every step along the way, we know where they came from. So this is maybe a little bit more of those novelty types where we know the origin, we know what bones and many of the steps along the way, but it's still a brand new function. So a novelty can be something that we really have no idea about, something that we don't have any evidence or steps along the way. Those are really more of the mysteries. It can be something that we have a couple ideas about but aren't sure exactly where it originated. Or it can be something that we know pretty good or maybe even very clearly where it came from and originated, but it's given these organisms a new function and a new feature that was unavailable to them prior to them evolving this feature. So we're going to look at, I think, 7 in total. The last 4 are all going to be vertebrates, but we're going to look at 7 novelties and look at our understanding of how those new features, those things came about. We'll do those in subsequent lectures. I'm breaking this down into shorter pieces. It'll be a little bit easier to go over and review, and also you don't have to sit down through one long lecture. The panda's thumb is another interesting morphological novelty that we know its origin, and even if we don't know all of the steps or if it was a single mutation that led to it, we know where it came from. So this is a picture of a panda's paw, the forelimb. Now if you notice, the first thing that jumps out at you is 6 digits. Now in reality, there aren't any living vertebrates that have 6 digits. Our ancestors had 5 digits, and all organisms today have either 5 or fewer. So there have been many groups that have lost some of their digits. And even though there are fairly common polydactyly mutations in individuals, so mutations in cats or in dogs or even in humans, right, where we have an extra digit, that's a frequent mutation, yet none of those have provided enough of an advantage to become a feature of a species. So even though they happen commonly, we don't have any species with 6 digits in the vertebrates. Now, you're saying, well, wait, here's a panda, I count 6 digits. And this is a really interesting one because they actually only have 5 digits. So when we say the panda's thumb, we should perhaps put thumb in quotation marks. When we look internally, it's very obvious that this thumb, quote unquote, is actually a modified wrist bone. And it serves a key purpose for these panda bears. It allows them to grab, it serves just like a human thumb, provides extra dexterity and allows them to grab and manipulate their food, bamboo, right? These are vegetarian, completely vegetarian bears. And so it's actually a key thing. Their forelimbs have this extra modified wrist bone that works a little bit like a thumb, and so it's been an important adaptation for them. And so we know where it came from. We can homologize the quote-unquote thumb with the wrist bone found in other close relatives and even other distantly related mammals. So it's very clear where it came from, just like we can trace through the fossil record the origin of what was once very large bones aiding in jaw attachment to a reduction and modified function for the inner ear bones of mammals. So any feature that's been modified now performs a new function. That can be considered novelty, but some novelties are much more mysterious, or at least maybe a better term is we don't have good data supporting their origin or the steps along the way for their origin. Now, one last concept that I want to hit and that we haven't talked about yet, and this is this idea of a novelty as a key innovation. So a key innovation is any novel structure that provides a huge advantage. So it's a really large adaptation. And in fact, a key innovation is one of sometimes many and sometimes just a few, or maybe even it might be unique. But it's one of the things that defines the success of a group. So for instance, wings in insects are a key innovation. And there are some others that have also allowed insects to become hyper successful, at least as far as biodiversity goes. But wings certainly are maybe the most important feature that evolved and allowed insects to thrive and do very, very well. And so all of these, to some extent, could be considered key innovations for their groups, but some are more important than others. So the flukes of whales certainly has allowed for the vast success of this group and their dominance in these big niches in the top predators in the ocean environment. The inner ear bones, right? This has allowed for hearing, but other organisms can hear well. So inner ear bones, although they do provide an important function, it's really kind of an alternative pathway to something that organisms were already doing fairly well. And although this might provide an extra level, it's probably not as good of an argument for a key innovation as some of these others. The panda's thumb, maybe we would consider it on a very narrow scale a key innovation because it's allowed pandas to be successful in their environment, but it really hasn't resulted in massive biodiversity and success of the group. So you'd be hard-pressed to argue the panda's thumb as a key innovation, although it certainly is a novelty and provides a function for that one species. Okay? So key innovations are novelties that then result in success. And we typically define success in terms of either length and survival in the fossil record, or even better, biodiversity. Now, another key innovation that has occurred 4 times, and we're going to talk about in our next 2 lectures, kind of tangentially in our next lecture and then directly in the lecture after that, is flight. Right? Wings have evolved 4 times, and so wings were a key innovation for insects when they evolved. They were the first organisms to evolve flight. But as later groups evolved flight, they also saw massive success, and we'll go into this in more detail when we look at feathers and then insect wings in detail. But the 4 groups that evolved flight, the earliest in the fossil record were insects, and it led to great success. The next that we have a record of are the pterosaurs. The pterosaurs were a group of diapsids, and they were incredibly successful. Now, wings were not enough to allow them to survive the mass extinction event at the end of the Cretaceous period, about 65 million years ago. That mass extinction event wiped out many of the large dominant diapsids, including most of the dinosaurs, but not all. Remember, birds are a living remnant of that dinosaur group. It wiped out the pterosaurs, the ichthyosaurs, the plesiosaurs, and kind of changed very much the foundations of our ecosystems. In the last 65 million years, mammals have been the beneficiaries of those extinctions because they have filled up many of the niches that were vacated by extinction of those large diapsids. So birds were around at that extinction event. Birds were the 3rd group of organisms to evolve true flight, a small group of theropod dinosaurs that evolves feathers and eventually evolves flight. and that allowed them to be hyper successful, diversify, spread across the globe, and it was enough for the birds to allow them to survive that mass extinction event. So a really clear key innovation for the birds. And then finally, as I've got pictured here, bats. Bats are the most diverse and successful, widespread group of mammals. And there's just a few of the diversity of forms that we see in bats. Bat wings were the fourth true wing that evolved in the history of life on Earth. And it occurred after that Cretaceous extinction event. So they were part of the rapid expansion of mammals to fill up those niches, and are probably filling niches perhaps that pterosaurs filled, although we don't have much good evidence that pterosaurs were nocturnal. So in some ways bats may be filling partially some of those flying niches, but also have carved out an additional niche of their own, because in addition to wings, they also have another key innovation. So really we could say there are two things that makes bats so successful amongst the mammals. They have all the features that made mammals successful also. But bat key innovations include both a ability to fly and the ability to echolocate, which not all bats use, but is an important feature in the most diverse subcategory of the bats. So anyway, just review, make sure you know what a key innovation is. You should know some of these examples, but in the coming lectures, we are going to go into detail about the origin and our understanding about how some major key innovations, some of these new novelties that resulted in hyper successful groups, how they came about.